Okay, in this video I'm basically going to do a three equation linear system here and show you how you can use the Gaussian elimination and Cramer's rule to solve for this one. So now let's first start with the Gaussian elimination here. So the first thing we have to do is rewrite this in argumented matrix form. What I'm going to do is like write the coefficients. Remember here you'll just have to consider like the coefficients of this one. So what you have is 1 minus 1 and 2, and the coefficients of the second one, what you have, it's 1 2 and minus 1, and the coefficients of z you have are 1 minus 1 and minus 2. You have an equal sign, then you have 6 0 and minus 6. So you have something that looks like this. So now what we want is to obtain zeros everywhere except diagonally. And we have to simplify the diagonal to be equals to 1. We must get 1, 1, 1. That way we can get x, y, and z. So now, let's start. So we're going to have to make this one to be equals to 0. We want to make a 1 equals to 0. How can we do that? We can replace row 1 by row 1 plus row 2. That way, if we replace row 1 by row 1 plus row 2, we can be able to get this one to be equals to 0. So let's do that. But now realize that if we do this type of transformation, we'll end up having a problem, since like minus 1 plus 1 is equals to 0. We don't need a 0 here. So that means we'll have to think of another method of solving this. So for now, let's just leave row 1 as it is. And then looking at row 2, we want to obtain 0 here. So we can replace row 2 with row 2 plus row 1. That way we can get 0 here. And then looking at row 3, we want to obtain a 0 here as well. So we can replace row 3 with row 3 minus, we can say row 3 plus 2 row 2. Row 3 plus 2 row 2. That way we can get this one to be equals to 0. So we left row 1 as it is, 1, 1, 1, and 6. And then we have minus 1, 2, and minus 1 here. And then we're replacing that row with row 2 plus row 1. So minus 1 plus 1, that's going to give us 0. 2 plus 1, that's going to give us 3. And minus 1 plus 1, that's going to give us 0. 0 plus 6, that's going to give us 6. And then row 3, we're replacing row 3 with row 3 plus 2 row 1. And then when we do that, row 3 plus 2 times minus 1, that's going to give us 0. We have minus 1 plus 2 by 2, which is going to give us positive 3. And then minus 2 plus 2 into minus 2, that's going to give us, 2 into minus 1, that's going to give us 2 by minus 1 is going to give us minus 2, and then we have minus 2 minus 2. Then that's going to give us minus 4. And then minus 6 plus 2 into 0, that's going to give us minus 6 still. So we have something like this. Now what we want is to like obtain a 0 here. Basically, we want to obtain a 0 somewhere there. So what we can do is like replace row 1 with 4 row 1 plus row 3. We can do that. We can replace row 1 plus, 4 row 1 with 4 row 1 plus row 3. That way we can get 0 here. So now we have 4 times 1, which is 4, minus 4, since it's plus into minus 4, that's going to give us 0 there. So we have 0. And then we have 4 times 1, which is 4, and then we subtract, we add it with 3, and then we get something like 7. And then we have 1 times 4, which is 4, and then we add it with 0. It's just going to give us 4. And then what we can do is like divide row 2 by 2. So we just half row 2. So we half row 2, then, we divide row 2 by 3, so we can get 1 here. So we have 0, 1, 0, and 2. And remember, for here, you have to make that changes here as well. So we have 4 by row 1, which is 4 by 6, which gives us 24. And then we add it with minus 6, which is going to give us technically 18. So we have something like this. And now we want to obtain a 0 here as well. So we can replace row 3 by row 3 minus row 2. So that way we have 0 minus 0 giving us 0, and then we have 3 minus 3 giving us 0, and then we have minus 4 minus 0, which gives us minus 4, and then we have minus 6 minus 6, that's going to give us minus 12, and then we have something like this. Now what we want as well is to obtain 0 here as well. So we want to obtain a 0 there as well. So what do? We can replace row 1 by row 1 minus 7 row 2. We can replace row 1 by row 1 minus 7 row 2. And that way, and then row 3, we can divide row 3 by minus 1 over 4. So we get something like that. So here we have 4 minus 7 by 0, which is 4. And then we have 7 minus 7 by 1, which is going to give us 0. And 0 minus 7 times 0, which is 0. And then 18 minus 2 by 4. 2 by 4, 2 by 7, it's going to give us 14. Then we have 18 minus 14. And 18 minus 14, that's going to give us 4. And then row 2, we leave it as it is, 1, 0, 0, and then we have 2 here. And then we divide row 3 by minus 4. Then we have 0, 0, minus 4 divided by minus 4 is going to give us 1. And minus 12 divided by minus 4, that's going to give us 3. So we have something like this. So now realize something. Row 1, we still have 4 here. We have to divide, we have to replace row 1 by 1 over 4 row 1. That way we can get this to be 1. So that means we'll have 1, 0, 0, and then 1. Since 4 divided by 4, it's 1. And we have 0, 1, 0, and then we have 0, 0, 1, and then we have 2, 3 like this. Remember, now that you have 1s diagonally, so like this, that means like x here will be equals to this value. So that technically implies that x will be equals to 1, and this value here it's for y. That means that y will technically be equals to 2, and then that value here it's for z. That means that z will be equals to 3. So that's how you can like use the Gauss elimination to find x, y, and z. Okay, so now since we find the solution using the Gaussian elimination, let's see if we can find this using Cramer's rule. So now before we do that, there's something I'd like to show you about using Cramer's rule on a 3 equation system here. So since like the Cramer's rule is technically associated with determinants, your determinants, when you form them, follow this rule. So you're basically going to have either A or D first, and then C or D last. So this one will technically be the first, and this one will be the last. The reason I'm showing you this is technically so that you don't mess up how you write your determinants. So it's either A or D first, C or D last. A gets first preference and C gets first preference. And this is the A, B, C, D, and this is the A, C, D. It has nothing to do with B. B can never be first or last. Okay, so now let me recopy the equation here. So I technically have x plus y plus z equals, okay, let me just rewrite this just a sec. X plus y plus z equals 6. And then minus x plus 2y minus z equals 0. And then we have 2x minus y minus 2z equals minus 6. And remember I said A or D first, C or D last. No, keep this in mind. So now we want to find the determinant excluding the constants. And let me write A, B, C, and D. So you're following this rule. So we want to find the determinant excluding the constants. This ones, we want to exclude the constants. So when you exclude the constants, can A be first? Yes, because we can basically follow this one. So now, so then you technically have 1, minus 1, and 2. So it's A first. And then what happens? Can C be last? Yes, because it's technically associated with Z here. So we have 1, minus 1, minus 2. Those are the coefficients of Z. And then this one, remember we're excluding the constant. What's left? What's left is B. So you just copy B, which is just 1, 2, minus 1. Then you technically evaluate that determinant, which I showed you how you evaluate that determinant, so it shouldn't be a problem. So then you have 1 by 2 by minus 2, then it's going to be minus 4. Then you have 1 by minus 1 by 2, that's going to give us minus 2. And then we have 1 by minus 1 by minus 1, that's going to give us positive 1. Then you subtract, open brackets, and then you have 2 by 2 by 1, which is just technically going to give you 4. And then you have minus 1 by minus 1 by 1, which is just technically going to give you plus 1, and then minus 2 by minus 1 by 1, which is just going to give you positive 2, like that. So then you further simplify. Minus 4 minus 2 minus 6 plus 1 minus 5. And then 4 plus 1, that's 6, plus 4 plus 1, it's 5, plus 2, it's 7. Then you have minus 5 minus 7, which is technically going to give you minus 12. So you have this determinant now. So now you want to find the determinant excluding the x coefficients. So that means we exclude A. So A cannot be first. So that means D goes first. So you have 6, 0, and minus 6. And then, since D is first, can C be last? Yes, it can be last. So you have 1, minus 1, and then minus 2 here. And then, what remains? What remains is 1, 2, and minus 1. So you have 1, 2, and minus 1. Then, you copy the first two columns, and then minus 6, minus 1, and then you have 6 by 2 by minus 2, that's technically going to give you minus 24, and then you have 1 by minus 1 by minus 6, which is technically going to give you positive 6, and then this was going to give you 0, and then you subtract, open brackets, minus 6 by 2 by 1, that's going to give you minus 12, and minus 1 by 6, that's going to give you positive 6. Then minus 1 by okay, so I have minus 2 by 0 by this one, which is simply going to give you 0. So that's all you have. And then you simplify. So you have minus 24 plus 6, that's going to give you minus 18. Minus 12 plus 6, that's going to give you minus 6. The negative into negative is going to be positive. Then you have 6, and then this one you have minus 12 there. And then now you find the determinant excluding the y's here. When you exclude the y's, can A be first? Yes. So then technically you just copy the coefficients of x, 1, minus 1, and 2. And then can C be last? Yes. So you copy the coefficients of z, 1, minus 1, minus 2. And then you follow up by whatever that remains. You're excluding B. So that means like you'll remain with D in between. So you'll have 6, 0, minus 6. And then you evaluate that determinant, so it shouldn't be a problem. Then you have 1, 6, minus 1, and 0, 2, and minus 6, like that. Evaluate that determinant, then just pause the video and see if you can find that determinant. So if you work that determinant, I want you to work it out, you get minus 24. Also use this rule to find the determinant of z. I'm just, technically, you just watch it and not practice this, which is really not helpful. This one you'll get minus 36. And then after you get that determinant excluding the z coefficient, then you're done. So x will be equals to the determinant excluding x over the determinant excluding the constant. Y will be equals to dy over d, and then z is equals to dz over d. Then from here, it's just a matter of like plugging everything in. So x equals, what did we find dx? It's minus 12. And then d, we solve d to get minus 12 as well. And y, dy, we got minus 24 there, which I said you should work it out and see if you get the same. And then z, you get dz as minus 36, and d, it's minus 12. Then when you get here, you get x equals negative 12 over negative 12 is basically 1. And y equals negative 24 divided by minus 12 is technically going to be 2. And then minus 36 divided by minus 12 is technically going to be 3. So this is using Cramer's rule to solve that. And this was the Gaussian elimination. So you see you still get to the same correct values here. So that's how you can evaluate a 3 by 3 determinant, and also a 3-equation linear system using Cramer, and also the Gaussian elimination. Don't forget this. Try another equation and see if you can solve it using Cramer and then the Gaussian elimination. So thanks for watching. Don't forget to share and subscribe.